Okay. As far as the test is concerned, I have not graded it as yet, so I don't have any feedback for you at this moment. My goal is to get it all graded tonight, and then if anybody wants to come see me tomorrow or the day after for tutoring, I'll be happy to hand you back your test at that time. And you can also do test corrections at the same time in the tutoring lab. So it's a win-win situation if you decide to take it. Um, yeah. Other than that, questions, please. I'll give you guys a few minutes in case you want to open up WebWork to get a question or two. Okay. Let's say let's say 212, 213. Right? I'll let you guys search around, and if you have any questions, just unmute and ask. All right, all right. Any questions, you guys? Nobody can find anything? All right, so let's jump into today's lesson. So, we spoke about how to simplify radicals, right? So now we're going to talk about how to add, subtract, and multiply the radical expressions. However, before we get into that, I want to do a little blast from the past with you guys. All right? A little bit of an older question here. Who remembers how to do this? Anybody? All right. So the way that we do this, I'm going to do this on the bottom, is that we distribute the negative onto every term on the right-hand side. All right? Just like so. And then I'm going to have 3x squared, just bringing down the polynomial on the right on the left-hand side, 3x squared plus 9x minus 5, distributing a negative, so then now we have minus x squared. A negative to negative is positive, plus 2x. A negative to a positive is a negative, minus 3. Right? After that, what do we want to do? We want to combine like terms, right? Combine like terms. So 3x squared minus x squared is going to give me a 2x squared. 9x plus 2x is going to give me a positive 11x. And negative 5 minus 3 is going to give me a negative 8. All right? And then this is my answer. Remember how to do this, right? It's just adding polynomials. A little blast from the past. All right. Over here, I want to simplify this, right? So this is just multiplying polynomials, and you remember how to do this, right? We're going to FOIL it first, outer, inner, and then last, right? Let's keep it moving. 2 times 4, we know that's 8. And then 2 times negative a is going to be negative 2a. And then a times 4 is going to be a positive 4a. And then a times negative a is going to give me a negative a squared. Then I want to combine like terms. This is going to give me 8 plus 2a minus a squared. You could leave it like this, or you could put it in descending order. You could give me negative a squared plus 2a plus 8. All right. I would accept both answers here. All good? All right. All right. Oh, this one's bringing is going to bring back some memories right here with this one, right? So I squared this term here, right? Well, these two terms, excuse me, this binomial expression, I squared it. Now, remember we had a formula, right? A minus B squared is equal to A squared minus 2 times A times B plus B squared, right? Right? And that's what we're going to do over here. Let's take a look. I have 9 minus 5y squared, so you already know. What's this going to be? This is going to be 9 squared minus 2 times 9 times the 5y plus, right, the 5y, sorry, I forgot the parentheses here, squared. Going through the math, blah, blah, blah. I have 81 minus, ooh, what's that? 90y plus 25y squared. I would accept this, or if you want to give it to me in descending order, you could say 25y squared minus 90y plus 81. I'd accept either one of these answers. Questions on these? Anybody? Anybody have any questions? Okay, let's keep it moving. All right. Let's talk about adding and subtracting radical expressions. So, adding rational expressions with the same index and the same radicand, right? Radicand is what's inside the radical. Index is the kind of radical you have. If you have square root, cube root, etc., right? Is like adding like terms. We call radicals with the same index and the same radicand like radicals. To remind us, they work the same as like terms. Okay. Just for clarification, like radicals are radical expressions with the same index and the same radicands, right? We add and subtract like radicals in the same way we add and subtract like terms. We know that 3x plus 8x is 11x. Similarly, we add 3 square root x plus 8 square root x, and the result is 11 square root x. Think about adding like terms with variables as you do the next few examples, right? When you have like radicals, you just add or subtract the coefficients. That's the number that's in front, right? When the radicals are not alike, you cannot combine the terms. Okay? So in that case, you leave them separate and that's your answer. Let's look at this example. Okay. First off, it says, I want to simplify 2 square root 2 minus 7 square root 2. All right? So for part A, I have 2 square root 2 minus 7 square root 2. It appears right? As if I have the same radicals, right, with the same radicands, right? So I can just deal with the coefficients in front. So 2 minus 7, right? That's going to be what? Negative 5. So negative 5 square root 2 is the answer. Questions on that? All right. Let's look at B. I have 5 cube root of y plus 4 cube root of y, right? I have the same radical, right? And the same radicands. Just dealing with the numbers in front. 5 plus 4, that's 9 cube root of y. Let's take a look at C. I have 7 fourth root of x minus 2 fourth root of y. Now, I have the same radical, but I have different radicands. That being said, this is my final answer. No work needs to be shown. Is there any questions on this? Any at all? Okay. I'll let you guys try. Try this out. Thank you. All right, let's take a look. So for A, sorry about that. 1 second. So for A, I have 8 square root 2 minus 9 square root 2. I have the same radicands. I have the same radical, right? So just dealing with the numbers in front. 8 minus 9, that's negative square root 2. You could also say -1 if it makes you happy. Not necessary, but if it makes you happy. Right? Looking at B. I have 4 cube root of x plus 7 cube root of x. It appears I have the same radical and I have the same radicands. So I'm just dealing with the numbers in front. So 4 plus 7, what's that? 11, I think. cube root of x, right? How about C? For C, I have the fourth root of x minus 5. I'm sorry, I have 3 fourth root of x, apologize, minus 5 fourth root of y, right? I have different radicands in this situation, right? So therefore, this is my final answer, and I'm done. Is there any questions on this? Any at all? All right. For radicals to be like, they must have the same index and radicand. When the radicands contain more than one variable, as long as all the variables and their exponents are identical. The radicands, right, are the same. Okay. Let's take a look at this example right here. I'll give you guys one to try. So in this example for A, I have 2 square root of 5n minus 6 square root of 5n plus 6 plus 4, excuse me, square root of 5n, right? So 2 square root 5n minus 6 square root 5n plus 4 square root 5n. Next, I want to combine like terms. 2 minus 6, right? That's going to give me a -4, and -4 plus 4 is what? This is going to be just plain old 0. Easy question. For B, I have the fourth root of 3xy plus 5 fourth root of 3xy minus 4 fourth root of 3xy, right? 1 plus 5 is 6, minus 4 is 2. So final answer, 2 fourth root 3xy. All right. Any questions on this, please? Anybody? All right. If there's no questions, let me give you guys one to try. Okay. Try that out. All right. We're just trying out this problem right here. Remember, combine like terms. All right. So I have I have the square root of 7x minus 7 square root 7x plus 4 square root 7x. I have the same radical, the same radicand, so I'm just dealing with the numbers in front. 1 minus 7, -6, and -6 plus 4, -2. All right, looking at B, I have 4th root of 5xy plus 2 fourth root of 5xy minus 7 fourth root of 5xy. So now 5xy times 2. Thinking. Let's combine like terms, right? 4 plus 2, 6 plus -7 is just going to give me a negative fourth root of 5xy. And that's it. Questions on this, please. Okay. So remember that we always simplify radicals by removing the largest factor from the radicand that is a power of the index. Once again, each radical is simplified. We can then decide if they are like radicals. All right. Let's give an example. So let's look at example A. Not really interested in example B, but we're just going to look at A. I have square root 20 plus 3 square root 5. All right. Now I could break down the 20 into what? This becomes square root 4 times square root 5 plus 3 square root 5. Square root of 4 we know is 2. So this is 2 square root 5 plus 3 square root 5. Call that 5 square root 5. Not so bad, right? For B and for C, same game. You would just find the perfect squares that, excuse me, the perfect index that goes into each one. So for B, will be the perfect cube. For C, will be the perfect fourth root that goes in. And then that's it. I'm just keeping it simple. I'm going to give you guys a chance to try. Try this. Go ahead. All right, let's take a look. Just gonna do A. I have square root 18 plus 6 square root 2. All right. Largest perfect square that goes into 18, we know this is going to be square root 9 times square root 2 plus 6 square root 2. Square root of 9, we know is just 3 square root 2 plus 6 square root 2. After that, combine like terms. 3 plus 6, this is 9 square root 2. And then that's it. Questions on that, please? Anybody? Got you, got you. All right, let's take it up a notch real quick. Let's take it up a notch. So let's look at A for this one. All right. So for A, I have 9 square root 50 m squared minus 6 square roots 48 m squared. All right. Now, I know that the largest perfect square that goes into 50, for example, is 25. So I'm going to rewrite this as 9 square roots 25 m squared times 2 minus 6 square root, right? Largest perfect square that goes into 48, I believe, is 16. So 16m squared times, if I'm not mistaken, I think that's 3, right? 16 and 16 is 32. Add another 16 on that, 48. Okay. Now let's break them out of their square roots, right? So this is going to be 9 times 5m square root 2, right? That's what the 25m squared is becoming, 5m, minus 6 times, what's this, 4m, and you're going to have the square root 3. Let's combine like terms or multiply whatever. 9 times 5. This is 45m square root 2 minus, so 24, 24m square root 3. Now I want you to notice something here, right? My radicals are different. They have different radicands. Same kind of radical, but different radicands. So that means that I'm done, right? There's nothing more I can do. Keep them separate. That's the end of the question. And that's it. That's how we do this, right? Let me give you guys one to try. I'm gonna give you guys one to try. Try that out real quick. There you go. Give it a whirl. All right, let's take a look. I'm gonna look at A. So square root 32 m to the seventh power, right? Perfect square. Largest perfect square that goes into that, I believe, is 16, right? And then we're gonna have m to the six because six is divisible by two because remember this is a square root, power of two right there. And what's that gonna leave back? That's gonna leave back a two and an m minus largest perfect square into 50 we know is 25, and this is gonna be an m6 as well. And that's gonna leave back a two and an m, right? Simplifying this down, I'm gonna get 4m cubed, right? Square root 2m minus 5m cubed square root 2m. Now, I notice that they have the same exponents, m cubed, and they have the same radical, the same radicand, so I can just deal with the numbers in front. So 4 minus 5, that's going to give me a negative m cubed square root 2m. Right? Now, if it makes you happy, you can also give me -1. Don't have to, your choice. And then that's it. All right? Let's keep it moving. So I just want to jog our memories for a little bit before we go a little bit deeper. Okay. So you guys remember the product property of roots, right? So for any real numbers, excuse me, the nth root of A and the nth root of B for any integer n greater than or equal to 2, the nth root of A times B is equal to the nth root of A times the nth root of B, and the nth root of A times the nth root of B is equal to the nth root of A times B. All right? Remember this property, right? We're about to play with it a little bit. Let me just make a comment real quick. All right. So when we multiply two radicals, they must have the same index. Once we multiply the radicals, we then look for factors that are a power of the index and simplify the radical whenever possible. Multiplying radicals with coefficients is much like multiplying variables with coefficients. To multiply 4x times 3y, we multiply the coefficients together and then the variables. So the result is 12xy, right? So keep this in mind as you do these next examples. Excuse me. So check this out. Oh, this is going to be a good one right here. Yes, sir. So I'm gonna look at A real quick, right? Now we're jumping into multiplying them. This is gonna be a little bit easier, right? Here's what I want you guys to remember. Numbers with numbers, radicals with radicals. All right? I'm gonna say that again. Numbers with numbers, radicals with radicals. So 6 times 3, what's that? That's 18, right? And then radical 2 times radical 10, that's radical 20. But I can't leave it like, right? That's right, because I have a perfect square that goes into the radical 20. So this is going to become 18 square root 4 times 5, right? And the square root of 4 we know is what? That's 2. So this becomes 18 times 2 square root 5. And just multiply those two together, right? So 18 times 2, what's that? 36 square root 5. It's that simple. It's that simple, right? Let me try out the B. -5 times -4, and negative times a negative is positive. 5 times 4, that's 20. Cube root of 4 times cube root of 6. What's that? 6 and 6 is 12. That's cube root of 24. But I'm not done because there's a perfect cube that goes into that, right? This becomes 20 root of what's this? 8 times 3, right? Check that. 8 and 8 is 16. Yep. And then the cube root of 8 we know is what? 2. So this becomes 20 times 2, cube root of 3. Let's call that 40 cube root of 3. And then that's my final answer. Is there any questions on how to multiply radicals? Once again, numbers with numbers, radicals with radicals. Any questions? And it doesn't matter if the radicals are the same, right? Or if they're different, right? Numbers with numbers, radicals with radicals. Questions? All right, I'm gonna let you guys try one. Try that out. I'm just gonna flash some water in my eye real quick because it's itching. Give me 1 second, I'll be right back. All right. So let's take a look. Once again, numbers with numbers, right? Radicals with radicals. So I'm going to look at A. I'm sorry. Hold on one second. Let me try that again. Okay, there we go. So for A, right? 3 times 2, we know is 6. And then we're going to have square root. 2 times 30 is 6. All right. Largest perfect square that goes into that, I believe, is 4. So this is going to become 6 square root 4 times, I believe, 15,
Wow.
right? And the square root of 4 we know is 2. So this becomes 6 times 2, square root 15. And then 6 times 2, this is simply just 12, square root 15. All right. Let's look at B. So for B, again, numbers with numbers, radicals with radicals, right? So 2 times -3, a positive times a negative, we know is a negative. 2 times 3, we know that is 6. Then we're going to have the cube root. 18 times 6, what's that? Woo, that's a good one. I'm going to cheat a little bit. 18 times 6, what's that? 108. 108. And then now we want to find out the largest perfect cube that goes into 108. I'm not going to lie to you, I have no idea. So let's break it down. All right. Start small, right? So I'm just going to chop this in two. So this is going to become 2 times 54 gives me 108. I'm going to break this down again, chop it in two. So this is like what? 25, 26, 27. It's 20. Oh, did I get that right? Yeah, 27. Yeah. Okay. And then we know that 27 is just 9 times 3. And we know that 9 is just 3 times 3. Right? So, largest perfect square that's going into this, I have -6. I mean, excuse me, perfect cube. Excuse me. Largest perfect cube that goes into this, we know it's going to be 3 to the third power times 2 to the second. And 3 to the third power will come out. So I have -6 times 3 cube root 2 to the second. Let's multiply these and get and simplify this. I have -18 cube root of 4. And then that's it. Questions on this? Anybody? Questions, anybody? Nothing? All right, let's keep it moving then. Let's keep it moving. So same idea. We're just going to be doing some more multiplications. Want to get that practice in. Homework for this section has already been posted, so you guys can take a look. All right. So once again, I'm going to say this one more time. Numbers with numbers, radicals with radicals, right? So real simple. So for A, keep it simple. 10 times 4, we know is 40. Square root 6p cubed times square root 3p is going to give me square root 18p to the fourth power. Just like that, all right? And then let's simplify it. Largest perfect square that's going into this, I believe, is going to be 9 p to the 4 times 2. All right. Break out those perfect squares. This is going to become 3 times 3 times p to the second square root 2. Multiply these out. 3, 6, 12. So this is about 120 p squared square root 2. And then that's my answer right there. All right. I'm gonna look at B. Let's take a look at B. Woo! B looks real. B looks real, but it's all right. We're gonna do it. We're gonna do it. Once again, let me start again. Numbers with numbers, radicals with radicals, right? 2 times 3, we know is what? 6, right? And fourth root, 20 times 28, I don't know. I'm not gonna lie to you, I don't know. Let me see. 28 times 2, 20. Whoops. Is 560. All right. So we got 560. And then x squared times x to the third, right? Whenever we multiply exponents, what do? We add them, right? So this is y to the fifth power. I'm sorry, did I say x? I should have said y. I apologize. Y squared times y to the third is going to give me y to the fifth. There you go, right? Now, I want the largest perfect fourth root that goes into each one, right? So we're gonna have the 6 on the outside, right? 560. Ooh, that one got me, right? I'm gonna have to break this down. So you know what? Let me make some more space over here. We're gonna do this on the side over here because this is gonna be a big one. Let me break this down. So this is 56 times 10. I'm gonna break down to 10. That's 2, that's 5. Let me break down to 56. That's 2, and that's like what? 25, 26, 27, 28. Let me break down to 28. That's 2, and that's 14. And then I already know what this is. That's 7, and that's 2. Okay. 1, 2, 3, 4 twos, right? That's what I want. 4 twos. So that's like 35 times 2 times 2 is 4, 4 times 2 is 8, 16, right? So I have the fourth root of 16 times 35 times y to the fourth power times y to the first, right? Perfect fourths are going to come out. So this is going to become what? 6 times 2 times y. And then we're going to be left with, in the fourth root, 35y. Put these together, this becomes 12y, fourth root, 35y. All right, that's not too bad. Is there any questions on this? Anybody? Anybody have any questions? All right, let's keep it moving then. Let's keep it moving. I'd like to give you guys a chance to try. Try that out. There you go. Try that out. All right, let's take a look at this. All right. So once again, numbers with numbers, radicals with radicals, right? Numbers with numbers, radicals with radicals. So 6 times 8, what's that? 6, 12, 24. Let's call that 48. I'm looking for at A, by the way. Let's call that 48. Excuse me. And then square root 6 times 30. What's that? Let's call that 180. X to the 6, right? Now let's pull out our perfect squares right there. So this is going to be 48. And I'm thinking definitely 9. I'm thinking, let's break this one down piece by piece, right? So I can see 9, right? I know that's 9, and then that's square root 20. No, something better than that. So 9 and 9 is 18, 36. That's the one. That's the number I'm thinking of. So 36 times x to the 6th power, right? And then just making sure. Yeah, that, and then times 5. Let me just verify that real quick. 36 times 5. Does that work? Yes, it does. Hallelujah. Okay. Square root of 36, we already know, right? That's going to be times 6. And then square root of x to the 6, we know that that's just going to be x to the 3rd power, right? And then, of course, square root 5, you can't forget about that. Last but not least, 48 times 6, going to cheat a little bit. So that's 288 x cubed square root 5. All right. Questions on that? Anybody? All right. Let's look at B. So for B, a negative times a negative we know is a positive. Call that positive 4. And then we have the 4th root. 12 times 8. What's that? Like 96? Y to the 6th power. Right? And then now we need the perfect 4th root, excuse me. That goes into 96. Let's do 96 on the side. I'm going to break this down by 2. So this is like what, 45, 46, 47, 48. I'm going to break this down by 2 again. Call that 24. Let me break that down by 2 again. Call that 12. And then 3, 4, and then 2, 2. So I have 1, 2, 3, 4. 4 twos and a 6. So this is going to be 4 fourth roots, 2 to the 4. Right? 1, 2, 3, 4. And then times y to the 4 times 6 times y to the 2nd, right? So I'm pulling out my perfect 4th roots, right? Gonna pull that out now. So this becomes 4 times 2 times y, 4th root 6y squared. And then now let's multiply this. 4 times 2, this is 8y, 4th root of 6y squared. And then that's it. Questions on this? Anybody? All right, let's keep it moving. This is what I want to get into next. All right. So I want to use polynomial multiplication to multiply radical expressions. So in the next few examples, we will use the distributive property to multiply expressions with radicals. First, we will distribute and then simplify the radicals when possible. This is going to be really, really fun, right? We're combining two ideas here, but we're already good at it. We're already good at it. So check this out, check this out, check this out. It's not too bad, right? So I want to take the square root of 6 and I'm going to distribute it over here and distribute it over here. You already know what's going to happen, right? This is going to become square root 12 plus square roots. Bear with me 1 second. Let's take a look. 18 times 6, what's that? Boom, 108. Now we want to look at our largest perfect square that goes into that, right? I believe for the 108, it could be 16. Nope, it's not. For sure, it's 9. Yep. So this is going to be square root 4 times 3 plus square root 9 times 12. Square root of 4, we know this is 2 square root 3 plus 3 square root 12. But wait a minute, I can still break down that 12 a little bit, can't I? Yeah, so this is going to be 2 square root 3 plus 3 times square root 4 times 3. Square root of 4 we know is what? 2, right? So this is 2 square root 3 plus 3 times 2 square root 3. Let's call that 6. This is 2 square root 3 plus 6 square root 3. Combine like terms. 2 plus 6, 8 square root 3. And then that's my final answer there. Questions on this? Just distributing, right? And then we're going to simplify and then combine like terms, and then that's it. All right? Same game on the other side. So I'm going to take cube root of 9, just distribute these out. So this is going to become 5 cube root of 9 minus cube root of 162, right? Now, 5 cube root of 9, you know, that's going to stay there. Let me see if 162, you have a 9. Okay, you have 18. So 5 cube root of 9 minus, um, hmm. 1 second. Let's see what 9 raised to the third power is. Nope, that's not it. So I got 2 9s and a 2. Nope, can't do nothing with that. Cube root 162. All right. Wait, hold up. You got 1. No, the 3s. That's what I'm thinking of. Yeah, I could break this down. 1 second. Hold up. 162, cut that in half. That's 81. That's 9 and 9. 3, 3, 3, 3. Right? So that's 27. So this is 5 cube root of 9 minus 1, 2, 3. So this is going to be cube root of 3 to the third, which is like 27 times 6. So this is going to become 5 cube root of 9 minus 3 cube root of 6. There we go. That looks a lot better. That's my answer right there. All right. Is there any questions on this? Anybody? Anybody. All we're doing here, right? Just a quick recap. We're just distributing, combining like terms, simplifying, all that good stuff. All right, let me let you guys try one. I'm gonna let you guys try one. Try that out. Go ahead. You guys can try that out. All right, let's take a look. Let's take a look. Doo, 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 doo. All right, so remember, we just distributing. That's all we're doing. Distribute, multiply, combine like terms, all that good stuff. Square root of 6 times 1 is just going to be square root 6. This is for A. Plus 3 square roots 36. And the square root of 36, we all know, is just plain old 6, right? Oops, so this becomes square root 6 plus 3 times 6. Let's call that square root 6 plus 18. And we're good to go. Let's look at part B. Cube root of 4 times negative 2 is going to give me a negative 2 cube root of 4. That's not bad. Minus cube root of 4 times negative cube root of 6 is going to give me a negative cube root of 6 and 6 is 12, 24. Now we already know this is going to be minus 2 cube root of 4 minus the cube root of 8 times 3. This is going to give me a negative 2 cube root of 4 minus 2 cube root of 3. Right? Different radicals, right? Can't be combined. They have different radicands. That's my final answer there. Questions on this? Anybody? Any questions? All right, let me make a special note real quick. All right. So when we worked with polynomials, we multiplied binomials by binomials. Remember, this gave us 4 products before we combined any like terms. Be sure to get all 4 products. We organized our work usually by the FOIL method, right? Remember how to FOIL? All right. Let's refresh our memories a little bit. So, excuse me. For A, I have 3 minus 2 square root 7 times 4 minus 2 square root 7, right? Very simple, very simple. All I'm going to do is FOIL. 3 times 4, that's 12. 3 times negative 2 square root 7, that's a negative 6 square root 7. Negative 2 square root 7 times 4, that's a negative 8 square root 7. And then negative 2 square root 7 times negative 2 square root 7 is going to be a positive 4 square root 49, right? Let's simplify this down. This is going to become 12 minus 6 square root 7 minus 8 square root 7 plus 4 times square root of 49, you know, is 7. Multiply this out. This is 12 minus 6 square root 7 minus 8 square root 7 plus 7 7 is 14. Let's call that 28. Now let's combine like terms, which is a fancy way of saying add, right? So 12 plus 28, let's call that 30, 40. Let's call it 40. And then negative 6 square root 7 minus 8 square root 7. Let's call that negative 14 square root 7. And there we go. That's it. Looking at B now. Same thing, right? Nothing changed. I'm just distributing, right? So cube root of x times cube root of x becomes the cube root of x squared. Then we're going to have cube root of x times 4. This is going to be plus 4 cube root of x. And then minus 2 cube root of x and then -8. Right? And that's simple. Let's combine like terms, right? Combine like terms. This is going to become the cube root of x squared plus 2 cube root of x -8. Questions on this? Anybody? Please. I can't simplify the x squared because it's not the same index as my root. So that's that. How did I get the 36? So the 36, trying to remember which question that is from. 36. It's probably from up here. Square root 6 times square root 6 is square root 36. That's how I got 36 there. Okay. Sorry about that. I didn't see the message until now. Okay. Not bad, not bad. I'll let you guys try. Go ahead, try that out. All right, let's do this out. I'm going to distribute 6 times 3. Let's call that 18. 6 times 4, square root 7. 6 is 12. Call that 24. Square root 7. Negative 3 square root 7 times positive 3 is going to give me a negative 9 square root 7. And then last but not least, a negative 3 square root 7 times a positive 4 square root 7 will give me a negative 12 square root 49. All right. And then we just want to simplify this. 18 plus 24 square root 7 minus 9 square root 7 minus 12 times square root of 49 is what? 7. Let's continue. This becomes 18 plus 24 square root 7 minus 9 square root 7 minus 7 times 12. 84. Let's combine like terms. Let's see, this is going to give me a negative 66 plus, what is that? This is like what, 15? Square root 7. There we go. That's nicer. So basically, you just FOIL, combine like terms, and then that's it. Let's take a look over here. I'm going to distribute this. This is going to give me a cube root of x squared minus 3 cube roots of x minus 2 cube roots of x. Negative is a positive 6. All right. Let's combine like terms. That's all we could do. Cube root of x squared minus 5 cube root of x plus 6. All right. So all we could do. That's it. Questions on this? Questions, anybody? All right. Now we got double radicals here, but it's the same game. Same game. Distribute, simplify. That's basically it, right? So 3 square root 2 is going to give me 3 square root 4 times, what's this, plus 12? Uh-huh. Square root 10. And then negative square root 5 times positive square root 2 is going to give me a negative square root 10. And then negative 4 square root 25. Let's break this down. 3 times 2 plus 12 Square root 10 minus square root, sorry, 10 minus 4 times 5. 6 plus 12 square root 10 minus square root 10 minus 20. Let's combine like terms, right? I have negative 14 plus 11 square root 10. That would be my final answer. Questions on this? Anybody? Once again, numbers with numbers, radicals with radicals. All right. I was looking for a good example. You guys try. All right, let's take a look. So we're going to distribute this, right? This is going to become 5 square root 9 times, oh, excuse me, plus 10 square root 21 minus square root 21, and then minus 2 square root 49, just like that. All right? Let's simplify this down. This is going to become 5 square root 9 plus, 5 times 3 plus 10 square root 21 minus square root 21 minus 2 times 7. Let's call this 15 plus 10 square root 21 minus square root 21 minus 14. Combine like terms. What do I get? 1 plus 9 square root 21. And that's it. Questions on this, anybody? All right. Just want to give you guys a little blast from the past real quick. This will help with the homework a little bit. Remember that we have our special products, right? So we have our binomial squares. So a plus b squared is equal to a squared plus 2ab plus b squared. A minus b squared is equal to a squared minus 2ab plus b squared. And we have our product of conjugates. A plus b times a minus b is equal to a squared minus b squared, right? These are our special products, and we can use them to help us answer some of our questions. For example, here we go. So question A is actually same thing like our binomial squares. So A plus B squared is equal to A squared plus 2AB plus B squared. We can use the same formula to answer this. 2 plus square root 3 squared. You don't have to memorize this, right? If you don't want to go through all of this, you can simply just make this square root, open parentheses, 2 plus square root 3 times 2 plus square root 3. And then you can just FOIL it like what we've been doing, and you will get back the same answer, right? Think of this as an alternative, like a shortcut to answering the question, what I'm going over right now. But if you can't remember this or you don't want to remember this, just remember that the little square right here means that you're multiplying two of them. So just put a copy next to each other and FOIL it, and then that's it. All right. So anyway, let me get back to this. This is going to be 2 squared plus 2 times square root 3 plus square root 3 squared, right? Simplify this down. What is this? This is 4 plus 4 square root 3 plus 3. Combining like terms, this is 7 plus 4 square root 3. That's my answer, and I'm done. All right. Let's look at B. All right. So we remember B looks like our other formula, right? Oops, excuse me. So this is A minus B squared is equal to a squared minus 2ab plus b squared. And then our question is 4 minus 2 square root 5. So let me write that down. 4 minus 2 square root 5. And we're going to square that, right? So that's the same thing as what? 4 squared minus 2 times the 4 times 2 square root 5 plus 2 square root 5 squared. Let's do the math on that real quick. What's that? 16 minus, I was about to say 8 minus 16 square root 5 plus what's this? 4 times 5, right? So 16 minus 16 square root 5 plus 20, combine like terms, 36 minus 16 square root 5. That's my final answer. And that's it. All right. I see that time is going on us. Let me just do one quick example of another kind, and then we can call it a day at that. So everybody check out this last example that we're going to go over. This one is going to look so cool, right? So this is multiplying two conjugates, right? They're opposites, right? Watch what happens when I multiply two conjugates. I'm going to do this in blue, right? So 5 times 5, we already know that's 25. And then 5 times 2 square root 3, this is going to be plus 10 square root 3. Minus 2 square root 3 times 5 is going to give me a negative 10 square root 3. And last but not least, negative 2 square root 3 times positive 2 square root 3 is going to give me a negative 4 times 3, basically. Right? It's going to be square root of 9, and you know square root of 9 is 3. Multiply these out, I get 25 plus 10 square root 3 minus 10 square root 3 minus 12. Let's combine like terms. Watch what happens. The middle cancels out. So this just becomes 25 minus 12, right? Which is going to leave me with what? 13, right? As a final answer. Is there any questions on this? This is multiplying the conjugates together. It's very cool. It's very cool. Matter of fact, tomorrow, excuse me, Tuesday, we're gonna actually use this when we start dividing, right? This is gonna be really, really cool. Any questions by anybody? All right, let's call it at that. Everybody, have a great weekend. All right. Thanksgiving break is coming up. Next week is Thanksgiving Pantry. Please, if you haven't done so, please register. Go get your free turkey or your free ham or your free fish or whatever it is that you want. All right. Everybody have an awesome weekend. Hashtag go Knicks, right? And I'll see you guys on Tuesday. All right. If you guys want your test back, right? Like earlier, like say you wanted like tomorrow or something, just come see me in tutoring. If that's not possible, then of course, by all means, Tuesday, I give them back in person, no problem. All right. So have a good night, everybody. I'm going to tutoring right now, by the way. So if anybody wants to join me, you're welcome to, right? Just log in, make the appointment, and just come in. No problem. All right. All right. Have a great weekend. Have a good night, everyone. Recording will be posted shortly, right? It'll get posted today, but give me some time. All right. Talk to you soon. Bye.